calculate Thevenin's equivalent network for the figure shown below. This is given figure and we want to draw its Thevenin's equivalent network. This indirectly we are interested in the calculation of the two values, which is VTH and RTH. How will be the calculations? Which method we will use here? जब भी हमें करंट कैलकुलेट करना है, ये टर्मिनल को हमें भूल जाना है, because we are interested in the calculation of the resistance or potential between the 2 points A और B में वोल्टेज चाहिए. This we are interested in the calculation of the current in this branch or this branch. ये दोनों ब्रांच में हमें करंट चाहिए. Right now, forget about this and forget about this. Now, ये दोनों branches में हमें current find out करना है. How to calculate current in these branches? Which method will be the suitable? Which method we will use for this calculation of the current? इसके current calculation में हम कौन सा method use करेंगे? Which method we will use for this calculation? Yes, anyone? If we are using the mesh analysis, how many meshes will be there? 1, 2, 3, 4. 4 loops. Otherwise, convert this current source to the voltage source. Then we will get 1, 2, 3 loops. And you can use direct inspection method or mesh analysis. Or without modifying, you can use the nodal analysis method. Now, how many nodes we have for this figure? Can anyone able to answer? And I want to prefer the method of your choice. आपको जो method अच्छा लगता है उसको हम follow करेंगे इस problem के लिए. If I'm using the nodal analysis method, what will be the number of nodes we have in this figure? That answer I want to know from your side. Then I will choose the method of your choice. Yes, anyone? Saurabh, Rishikesh.
Sir, 2 nodes.
2 node. कहाँ पे?
10 ohm 20 ohm के बीच में.
ये एक होगा.
और नीचे 0.
और?
Ground.
ये वाला.
Yes.
Anyone again? और किसी के पास आंसर है कोई? अविनाश, ऋषिकेश?
सर 20 ohm और 10 ohm के बीच में.
20 ohm और
10 ohm के बीच में.
Is it right? Means इस फिगर के लिए होंगे 3 nodes. This is 1, 2nd and 3rd. This is one branch. This will be the 2nd. This will be the 3rd. This will be the 4th. This will be the 5th, and this will be the 6th branch. ये होगा node A. Its potential is VA. This is node B. Its potential is VB. This is ground node. ये node नहीं होगा because this is one branch. क्योंकि इधर ये connected नहीं है. ये connected होता तो ये भी node होता. Is it right? Now, I want the suggestions from your side. Which method we will use here? इसको कन्वर्ट करके मेश यूज करना है या नोडल यूज करना है? चॉइस इज योर्स. यस, यस. सौरभ, रुचिरा, ऋषिकेश, माधुरी, छाया, अविनाश, आकाश. कौन सा मेथड यूज करना है? In this case, I will use the nodal if you are not suggesting, because conversion का जरूरत नहीं पड़ेगा. Otherwise, I have to redraw this figure. इसको फिर से redraw करना पड़ेगा. फिर loop 1, loop 2, loop 3 होंगे. Then we can use the direct inspection method. That is the case. Is it right? कौन सा method use करना है? सौरभ.
Sir, mesh analysis.
Mesh analysis. Okay, fine. We will convert this figure. इसको convert करते हैं. Now here is the point A. This is the 10 ohm. This is plus minus this point Yes, I will convert this to the voltage source. This will be the same. It will be something like this. This is plus and minus. It is something like this. This is 20 volt. This is 20 ohm. This is 20 ohm. It is 10 ohm. If we are converting, then it will be 10 ohm. And how much is the voltage? 50. This is 10 ohm. This is 10 ohm. It will be 30 volt. This point is the B point. Is it right? This will be the B point. Now we have the three loops. This is loop 1, which current I1. This is loop 2, which current is I2. And this is loop 3, which current will be I3. Is it right? Now here, in place of applying the cable to this loop, better way I will use the direct inspection. Okay? Come complicated hoga, come lengthy hoga. Is it right? Here, otherwise you can apply the cable to this, or you will get the similar equation. If I am using the direct inspection method here, this will be the set of first equation, this will be the set of second equation. I1, I2, I3, this is equal to the constants. Is it right? How will be the constants? I will discuss here. Here, this is the standard matrix. This is R11, R12, R13, R21, this is R22, this is R23. Finally, this is R31, this is R32, and this is R33. First, I will start with this R11. How much is the resistance of the first loop? This is first loop. How much is the resistance? 10, 10, 10, 30. This is 30. How much is the resistance of the second loop? This is the second loop. 10, 10, 20 will be 40. Is it right? And this is my third loop. How much is the resistance of this loop? 20, 20 is 40. Is it right? किसी को भी difficulty नहीं होना चाहिए. Then I will find out these two, R12 and R21, resistance which is common for the first and second loop. This is first loop, the second loop. Common is 10. This it is minus 10. This is minus 10. Is it right? Then I will find out these two, resistance which is common for the first and third. This is first and this is third. There is no common resistance for these two loops. 0. This is 0. Resistance which is common for the second and third loop, third and second loop. These two. Second, third, third, second. These two. 20. This is minus 20. This is minus 20. How are the constants? Now look at carefully. If we are traveling with the direction of the current, how much is the value? I am finding this value. If we are traveling with the direction of the current, this value will be plus 30. Is it right? This value will be plus 30. Then positive to negative, which is minus 50. How much is the resultant? Minus 20. This first constant is the minus 20. Are you getting me? If we are traveling with the direction of the current, look at the number of sources we have. Negative to positive plus 30, then positive to negative minus 50, resultant is the minus 20. Fine. If I am going for the loop number 2, how much is the value with the direction of the current? Negative to positive plus 50. There is no any source, means it is plus 50. For the third loop, if we are traveling with the direction of the current, positive to negative, which is minus 20, this is minus 20 is the value. Like we have this matrix. This matrix, same matrix can be obtained by applying the cable to the loop 1, loop 3. Three equations and arrange these three equations, we will get something like this. And from this matrix, we can find out its I1, its I2, sorry. First find out its I1, then calculate its I2, then calculate its I3. I don't know which currents we will require because 1, 2, 3 means I1 is required, I2 is required, I3 is also required. 3 currents. How are the values? I1, I2 and I3. Yes, anyone? How much is I1, how much is I2, how much is I3? Doesn't matter how the complicated is the figure. Important is how is your approach. That is the case. Yes. Anyone? Avinash, Madhuri, Rishikesh, Saurabh, Ruchira. Yes, Saurabh.
I1 minus 0.25.
Minus 45 amperes. Yes.
25, sir.
25. Minus 0.25.
1.25.
1.25.
25.
This is 1.25.
Yes. I3 0.125.
This is 1.5 amperes. This value is 1.25 amperes. This value is minus 0.25 amperes. Is it right? If we know the three currents, Ruchira, correct hai? Yes.
Yes, sir. Correct.
Correct. Okay, fine. Now we will find out the VTH, which is equal to. I will travel from the B towards A. Before that, as per this, it will be plus and minus because I2 is flowing. This is I3 से ये terminals होंगे, I1 से ये terminals होंगे. I am following these sign conventions, traveling from the B towards A by negative to positive plus. This is plus. How much is the value? 20 into ये common branch ये दोनों के लिए 20 into. If I am following the sign conventions of I2, then it will be I2 minus I1 because both directions are opposite. If we are following this sign convention, this is main current, this is sub current. Resultant will be something like this. The negative to positive, which is a plus, its resistance is 10 into its current, which is I1, which is equal to, this is 20. How much is the I2? I2 is 1.25 minus, sorry, not I1, this is I3. Because current in this branch, I2 minus I3. 1.25 minus, it is 0.125. This is right, plus 10 into I1, negative to positive, plus 10 into I1, and I1 is this value, which is minus 0.25. This is the VTH. Find out this value. Find out this value. How much is the value? This is 1.25 minus 0.125. This value is 1.125 into 20 into 20. This value will be plus 22.5. This is minus 10 into. This is 10 into minus. Sorry, 10 into minus 0.25. This value is minus 2.5. This is 2.5. And how much is the resultant value? This is 22.5 minus 2.5. 20. Is it right? 20 volt is the value of VTH. Correct answer? Check anyone. सही है क्या ऋषिकेश? सौरभ?
Sir, correct.
Correct. If we know the value of VTH, now find out the RTH. I will do little fast. RTH. हमें RTH find out करना है. Now look at how will be the RTH calculation. How will be the RTH calculation? All sources are replaced by respective interresistances. Load resistance यहाँ पे है नहीं because ये terminals already दिए हुए हैं. Here, for calculation of RTH, all sources are replaced by respective internal resistances. Is it right? I will draw this figure. This will be the point A. ये resistance as it is रहेगा, ये as it is रहेगा. This source we will replace by its resistance. उसके बाद ये रेजिस्टेंस ऐसे आएगा, ये सोर्स को हम रिप्लेस करेंगे, दिस विल बी समथिंग लाइक दिस, ये सोर्स को रिमूव करेंगे, दिस विल बी द अनदर रेजिस्टेंस, दिस विल बी द पॉइंट बी, राइट। और उसके बाद यहाँ पे एक रेजिस्टेंस है, इट विल बी समथिंग लाइक दिस, इट इज ऑफ 10 ohm, this is of 20 ohm, this is of 20 ohm again, this is of 10 ohm, this is of 10 ohm, and this is of 10 ohm again. This is A point and this is B point. This will be the figure for the calculation of RTH. ये सोर्स को रिमूव किया, इसको रिमूव किया, इस सोर्स को रिमूव किया, remaining everything is the same. Remaining everything is the same. How will be its next figure? Its next figure will be something like this. Its next figure will be something like this. ये दोनों parallel हैं, is it right? In this case, this is the A point. Here will be one resistance. These two resistances are replaced by the single resistance, which is 10 ohm. This parallel combination is 10. This is already 10. Then here is one resistance. This is another resistance, and this is the third resistance. Now look at this series and a parallel combination. This is 10 ohm, this is 10 ohm, and this is 10 ohm again. Now which resistance is in series and which is in parallel? What is the series and parallel combinations? There is no direct series and parallel combination. ये फिगर कुछ इस तरह से होगा. This will be the A point. There is one branch. This is the second. This will be the third. This will be the fourth, and this will be the fifth. Something like this. This is B. This is 10. This is 10. This is 10. This is 10, and this is 10. Now we have to convert any delta into its equivalent star. I will convert this delta into equivalent star. It will be something like this. In this case, this is A point. Here will be one resistance. This will be the second. This will be the third. Then it is fourth. And then this will be the fifth. And this is B point. This is 10 ohm. This is 10 ohm. How is this calculation? Otherwise, I will name this as R1, this is as R2, and this is as R3. How is the R1? This R1 is equal to this. It is connected between these two. This 10 into 10 divided by 10 plus 10 plus 10. This 10 plus 10 plus 10. How much is this value? 100 divided by 30. Its value will be, this is 100 divided by 30. This is value is 3.33. This value is 3.33. Same is the R2. This 10 into 10 divided by 10 plus 10 plus 10, this it is 3.33. And finally, this R3 is equal to 10 into 10 divided by this 10 plus 10 plus 10, this it is 3.33 ohm directly. Now these two are in series, these two are in series. This next figure will be something like this. एक resistance. These two resistances are replaced by the single resistance, which is 1. This is single. And this will be the B point. This 10 and this 3.33 is 13.33 ohm. This will be the same again, 13.33 ohm. This will be the 3.33 ohm. And here it is the A point and this is the B point. This figure is same as, how is the parallel combination of this 13.33 into 13.33 divided by 13.33 plus 13.33 is 6.665. This value is parallel combination is something like this. This is 6.665 ohm, and this value is 3.33 ohm. Now RTH is equal to 3.33 plus 6.665, 9.995. Or it is 10. This 9.995 ohm is the RTH. Now if we know the VTH and RTH, then we can draw its final figure, which is something like this. This is A point and This is the B point. It is the 9.995 ohm, and this source, which is the 20. The VTH is 20, and this is 20 volt, and this is the final answer because we are interested in the calculation of Thevenin's equivalent network for this given period.